Is my screen visible to you? Yeah.
Yeah.
Yeah. So as the demo class, I will give you the introduction to all the components, what is big data, and what are the components that are there in the world of big data, and what is their purpose, what is their role, and what are the components that are in trend now. That will discuss all about the big data. Okay. So first is start with big data. How do we define big data? What is big data? Okay, a data is something big. That says that data is something big. Okay, but the industry gave a definition about big data. That is a data having three V's: V first V, second V, and third V. This is variety and velocity and volume. Okay, data which has variety, velocity, and volume. If these three features are satisfied, then the industry is calling such data as big data. So let us see what is this variety, velocity, and volume. Velocity, before going to variety, first we should start with volume. Volume in the sense amount of data. Okay, if the amount of data is big, okay, and next, variety. What is the variety? Variety is the data can be either structured, semi-structured, as well as unstructured. There are three varieties of data. We can divide the data into three varieties: structured, semi-structured, and unstructured. If the data is structured, semi-structured, or unstructured, that is about variety. And if the amount of data is big, that defines the volume. What defines variety is these three different forms of data defines variety, and the huge amount of data, big amount of data defines volume. And coming to velocity, the data getting generated, okay, the data is getting generated very fast, very rapidly. Velocity, generally, what is the meaning of velocity? Velocity is the speed, the rate of speed. The rate of speed is called as velocity. So the rate of speed of generation of data is very fast, that is very rapid. So if the data is having these three varieties, and if the velocity, the rate of generation of data is very fast, and the amount of data generated is very huge. So if these three features are satisfied, then the industry is calling such data as big data. Okay, whereas variety, velocity, and volume. Okay, now. So what is the problem with this big data, and what is that industry wants to do with this big data? Let us see. So data, what the industry is trying to do with this data? Okay, big data, this big data, what the industry is trying to do? So why is such a huge demand for this big data? The main thing is increase in the usage of digitalization, digital world. Increase of, we can simply say that increase of the digital world, the rapid increase in the digital world. So everyone in today's world is using the, almost all the people are using mobile phones, laptops, and they are using several applications in mobile phones and in the from computers to make it in order to lead their regular life. They are using many applications. So consequently, what is going to happen is the amount of data is getting generated is very large. So mainly from these applications like social networking websites like some Facebook, and mobile apps like some WhatsApp, and video browsing, some YouTube video browser sites like YouTube, and there are many other, like Amazon, Alibaba. Okay, There are many other networking, social networking sites and shopping sites. So the thing is, the number of people registered in these sites, as well as the amount of data they are using, they are storing in these websites or in these servers is very, very huge. And the companies have to provide a platform. All the companies who are the companies have to provide a platform such that they have to provide flexibility in the usage of data. There should not be any limit on the usage of data, and the users you should have the flexibility to upload audio data, video data, textual data, different types of data. That is huge amount of data is getting generated on all these platforms. Huge amount of data and different varieties of data is getting generated. The users are dealing with different varieties of data. It will be some audio data, video data, and some textual data. Okay, so these are the scenarios where the amount of data is getting generated very, very huge, and that too with different varieties. So what these people have to do, these people have to retain the new customers, get the new customers, new users, or they have to retain the old customers, not to go away from their websites, by providing many flexibilities to them in usage of these particular applications. So for that, they have to attract their customers, they have to attract the users. How they have to attract? So that they can make their business, they can increase their business. Okay, so one thing is they have data. The data is getting generated, huge amount of data is there. Based on the data, taking that data, they have to increase their business. Somehow they have to increase their business. So if they have to increase their business, that whatever the data they have with them, the data must be processed. They have to process the data, then they have to get some information out of the data. Okay, so what is the information that they are going to get? So this data has to be processed. What are the data that they are getting from users, that data must be processed. And upon processing, what they are interested in getting out of the processing, after processing they have to get some information out of it. Information. So what information they are going to get, and what is that they are going to do with this information? With this information they are going to make business, they are going to increase their business. Okay, so that depends. So whether how on what basis they are increasing the business, that depends upon what type of information they are trying to get by processing the data. Okay, so we shall see what type of information they will get. That depends what type of information they are trying to they are trying to get to attract the customers or the users. That depends upon the application. Okay, suppose let us take Facebook. Let's take Facebook. So it gives a tag. Generally, almost all the people, all the computer users are having Facebook accounts. They will find one tag that you may know this person. You may know this person. We'll find something like this here. You may know this person in Facebook. How the Facebook is giving this recommendation to us. So you may know this person, and some pictures will be given under this, like this. Some pictures of some users, other users will be given under this. So how Facebook is recognizing that these are the people that may be known, who may be known to me, who may be known to the user. How it is getting this information, where from it is getting this information? So this information they are getting from our personal information, our interest, our hobbies, our likes, and our location, and based on some information that we are providing, and based on the browsing videos, based on the audios that we are uploading and watching regularly on the Facebook, they will try to find out the people with similar interest, and they will try to find out the similar people with same location. So based on some of these inform some of this data, they do process the data, and they will get some information. and that information, based on information, they are trying to give this, make this conclusion. So with this, what they are trying to do? They're trying to increase their business. They're making the users to spend their time in those applications. So obviously, when we spend some time in those applications, their business is going to increase. Okay. Similarly, when we watch YouTube, when we go to YouTube, there we find it will recommend, the YouTube will recommend to us that you may like this video, so the recommended videos for you. So how does it make recommendations? So based on our regular history, with regular browsing, based on our browsing history, it will try to conclude something about us, what type of video this user is interested in. So such information is going to extract from the data, from the processing, out of the processing, and it will give us recommendations. So when it gives recommendations similar to our interest, so what is that going to happen? So we spend more time in YouTube, we spend more time in watching the videos on YouTube, so that they will make business with the help of some what do you call as ads, by placing some ads in the videos. So there are several ways of making the revenue. Okay, so they will make revenue, and finally the target is they will increase their business. Okay. So thing is here, big data. So what the industry is doing with the big data is they want to process the big data so that they can extract some information out of it, so that they can increase their business. This is what happening. Okay. So in order to process this big data, what is that required? Okay. Let us see it now. So processing of big data. The first thing is processing. So if the big data has to be processed, before the processing, it has to be stored. It has to be stored somewhere. It has to be stored somewhere, then only it can be processed. Without storing the data somewhere, we cannot process it. Similarly, big data also has to be stored, and later it has to be processed. Okay. So where it has to be stored and where it has to be processed. So before this, there is a technology that has evolved to provide these two functionalities for big data, that is storage of big data and processing of big data. So Yahoo came up with invention of a new technology that is called as Hadoop. Hadoop is a new technology, or we can call it as a framework. A framework. So what is the purpose of this Hadoop? The purpose of this Hadoop is it can store and it can process any amount of data. We are saying that not just big data, any amount of data. There is no limit. The amount of data that Hadoop can store is there is no limit. It can store any amount of data in it. So either big data, whether the data is in gigabytes or terabytes or in zettabytes or exabytes, whatever it may be, whatever the amount of data, or in petabytes, whatever the amount of data, this Hadoop can store the data and can process that data. Okay, so this is a platform. Hadoop is a technology or a framework or a platform which is used for storing and processing huge amount of data. Okay, so how does it process huge amount of data? So for that, Hadoop has come up with two different inbuilt components. One is called as HDFS, another is called as MapReduce, and it's called as MapReduce. So this HDFS component is for storage of data, and this MapReduce is for processing of data. Okay, so what is our target here? The data has to be stored and processed. So Hadoop is a platform that I had told you. So in this, a component called as HDFS is used for storage of data, and MapReduce is used for storage of processing of data. This HDFS stands for Hadoop Distributed File System. Hadoop Distributed File System. Okay, it is a distributed file system, and MapReduce is a distributed computing system. Distributed computing system. Computing system. File system distributed, and computing system distributed. Just observe the word distributed here. What is distributed here? If we have huge amount of data, let us say some 100 GB of data, let us say 100 GB of data is there, then what we have to do, if we want to process 100 GB of data on a single machine, we cannot process this 100 GB of data. So what we can do, we can divide this data into multiple machines. We can divide the data into multiple machines. Likewise, whatever whatever the number of machines, okay, depending upon the size of the data, depending upon our requirement, we choose the number of machines. So if this 100 GB of data can be distributed into all these machines in the cluster. This we call as a cluster. So a group of systems, a set of systems connected in a network will form a cluster. And what this big Hadoop is, in Hadoop what we are going to do is, whatever is the amount of data, that data will be distributed among all the machines of the cluster. Once the data is distributed successfully, then with the help of an engine called as MapReduce, with the help of a component called as MapReduce, whatever the data that is stored in all these machines will be processed parallelly, at a time. All the data in all the machines will be processed parallelly. That is called as distributed computing, and HDF is called for distributed file system. The data is getting distributed and processing is also done in a distributed manner. That is why we call this as distributed computing system, and this file system we call it as distributed computing system. It is distributed file system. Okay, HDFS and MapReduce. Actually, this HDFS and MapReduce, these are the technology, these are the components of Hadoop. Just now we have seen that these are the components of Hadoop, but this is not the development of Hadoop is not an innovation. Is not an innovation. Okay, this Hadoop has been inherited. This Hadoop has inherited HDFS and MapReduce from Google. In Google, they had developed a file system called as GFS. It is called as Google File System. It was called as Google File System, and they have developed a computing system that is called as MapReduce. It is for computation. Okay, so Google, before Hadoop, Google had developed GFS, called Google File System, for storage of huge amount of data, and MapReduce for computation of that data. The same, the developers of Hadoop have taken their, the initiative. They have taken the features of HDFS and MapReduce from GFS and MapReduce. This GFS, this HDFS they inherited from GFS, and this MapReduce has been inherited from the MapReduce of Google. So Hadoop is not the innovation. It has inherited its features from Google implementation. Okay, remember this. So as we have discussed, HDFS is for storage and MapReduce is for processing. And what type of data can be stored in HDFS and what type of data can be processed by MapReduce? HDFS can store, this file system can store structured, semi-structured as well as unstructured data. Remember, HDFS can process structured, semi-structured as well as unstructured. Okay, storage point of view, okay, all the three varieties of data can be stored into HDFS. Then what about MapReduce? Yes, it can process again structured, semi-structured as well as unstructured data. Okay, so both HDFS and MapReduce, it can store all the varieties of data, and MapReduce has the capability to process all these three varieties of data. So big data can be stored and processed by using this Hadoop framework. This is the conclusion we can make. Okay, and whatever may be the amount of data, that doesn't matter. Okay, Hadoop has the ability to store any amount of data, and the MapReduce can process any amount of data, that too different varieties of data. Now we shall discuss now how Hadoop is able to store any amount of data. There is no, I have been telling that there is no limit on the storage of data in Hadoop. So how it is possible? Okay, let me tell you that also. So if there is the amount of data is huge, if the data is huge amount of data, then how Hadoop can be able to store this huge amount of data? Why it is not possible to possible with the traditional file systems? Why it is possible with HDFS only? Okay, now see this. Suppose we have a machine, we have some, let us say some PC or some lappy, we have some PC or laptop now. So the hard disk, generally we get some, now we are getting some 1 TB hard disk and 2 TB hard disk. Is it possible to store data more than 2 TB? Let us say the hard disk capacity is 2 TB in our PC or laptop. Is it possible to store data more than 2 TB in this? No, not possible. Why? Because the maximum capacity is 2 TB. If we want, if we want to increase the, still if we want to store some extra data into it, then what we have to do? Either we have to increase the capacity of the disk that is there in our PC or laptop, or we can use some external disk. We can use some external disk also. That is removable disk, plug-in disk. Either we can increase the size of the disk inside the machine, or we can attach one external disk. So which one would be comfortable? So if we go, let us say if we are going with some 4 TB of hard disk, okay, let us say our PC is supporting for it, and after some time again if we want to increase the capacity of our disk, let us go to some 6 TB. This PC or laptop may not support. Why? Because the depends upon the configuration, the memory, the motherboard, everything has to support, remaining all the components has to support for this storage of data. So a single machine, it cannot be used to store any amount of data. Then what is the option? The only option is we need to attach another device to it. The thing is, already we have one disk inside this machine. Now we need to, instead of increasing the capacity of the disk inside this machine, why can't we attach an external disk, so that the data can be there inside this disk as well as inside this disk. Okay, similarly the same concept is used in HDFS also. Let us say we have some 10 TB of data. Let us say we have 10 TB of data, and let us say each machine is capable of storing 1 TB of data. So how many such machines are required? We require 10 machines. Okay, 1 2 3 4 5 6 7 8, and let me add two more. Okay, 10 TB of data. Let us we are trying to store 10 TB of data. So if we are using one machine, each machine is, let us assume each machine of capacity 1 TB hard disk. Okay, so 10 TB can be stored in 10 machines. The thing is, we should have some file system so that 10 TB can be distributed into all these machines successfully. Okay, 1 TB in each machine must be accommodated. So who is going to do that? We are not interested, we can't do it, we won't do it. Okay, that HDFS file system will automatically distribute the data into all these machines. Okay, now it is okay with 10 machines, 10 TB. What if we get some 20 TB? What we have to do if we get some 20 TB of data? So if the capacity of each machine is only 1 TB, they can, collectively, even if we combine the capacity of all these machines, it can store only 10 TB of data, but not 20 TB. In this case, what has to be done? In this case, Shall we, there are two options. Either we have to increase the capacity of the disks of all these machines, or one more option is, why can't we add some extra machines? Add some extra machines. Add some more. Like we have 10, add 10 more machines. Add 10 more machines. Okay. Now the 20 TB of data is getting distributed into 20 machines. Okay. The 10 TB previously into 10 machines. Now 20 TB into 20 machines. Is it clear? So we need not to increase the capacity of the disk in all these machines. We may deploy, we may add whenever we want to, we can add any number of machines. Not just here only 10, we can add any number of machines, okay, in the cluster. That is, if we have one machine, if the capacity is not sufficient, if the capacity of this machine is not sufficient, we can add one more machine in the cluster. Okay, and if the capacity is not sufficient with these two machines, we can add one more machine in the cluster. Likewise, we can add any number of machines. Okay, this type of increasing the cluster size is called as scaling, and that too horizontal scaling. Horizontal scaling. So increasing the capacity of the cluster, that is scaling up, actually scaling up. Increasing, it is called as scaling up. Decreasing will be called as scaling down. Okay, so as we're increasing the number of machines, it is called as scaling up. What type of scaling is supported in HDFS or Hadoop environment? Horizontal scaling is supported and it is highly recommended. Okay, this is how HDFS can store any amount of data. If it is some 30 TB, some after some time, then we can deploy some more machines to accommodate that data. So no problem. Anytime, at any point of time, to already running cluster, we can add a new machine without any restarting of the cluster. We need not to shut down the cluster. Nothing is required. When the cluster is on, then in itself we can add a new machine to the cluster. Okay. So when the data is stored in all these machines, obviously what is going to happen, once the data is stored successfully, then a MapReduce will come into action. I told you that MapReduce is used for processing of data. So 1 TB of data is stored in all these machines. So instead of processing 30 TB in a single machine, now we are distributing 30 TB into 30 machines, let us say. So now MapReduce program, whatever the MapReduce application is there, that application will process the data present in all these machines at a time. Okay, so 1 TB in each machine is getting processed, and all the machines are processing the data at a time. Okay, so if the time taken to process 1 TB of data is, let us say, some 1 minute. If the time taken to process 1 TB of data is 1 minute, if we store the entire 30 TB of data in a single machine, and if we try to process it, how much time is it going to take? 30 minutes it is going to take, based on this assumption. And how much time this cluster is going to take? This cluster is going to take still 1 minute only. Why? Because in each machine we have only 1 TB of data, not 30 TB of data. So we could reduce the amount of time by 30 times. 30 times we could decrease the computing time. So this is the advantage we have with this big data framework, that is Hadoop. Okay, with respect to storage and with respect to processing. So this is a brief introduction to this Hadoop, HDFS and MapReduce. Okay. Now coming to this MapReduce and HDFS, and which file system would be convenient to use HDFS? Okay, HDFS can be installed on Linux machines as well as Windows machines also, as well as Mac also. Linux, Windows and Macs. So the industry generally goes with huge number. The most of the people in the industry go with Linux environment only. So either Linux environment, it supports RHEL, any Debian or any RPM, that is CentOS or Ubuntu or RHEL. All these Linux versions will be supported. Either they can go with Windows, Linux or Mac operating systems. Okay. Now coming to MapReduce. If the data has to be processed, any data has to be processed, what we need to do, we need to write some program, we need to write some logic. That logic we have to write in the form of a program. So if you want to write a program, a programming language is needed. A programming language is needed. So which programming language is needed? Okay, so the Hadoop, the entire Hadoop framework, HDFS and MapReduce, they are developed in Java language. So obviously, Java will become the native language of for writing the programs in MapReduce. Okay, so Java will become the native language for writing the programs of MapReduce. To process the data, we require a program. That program, for writing a program, we require a language. So what language? So as the framework is entirely developed in Java, they gave the API, MapReduce API in Java language only. But you may say that I am not good at the programming, but how shall I write the MapReduce programs? Okay, initially when Hadoop was developed, there were only these two components in Hadoop environment, HDFS and MapReduce. After that, Facebook has introduced a new component called as the Hive, and after that again, Yahoo has introduced one more component called as Pig. This is developed by Facebook, and this is developed by Yahoo. Okay, so they came up with two components called as Hive and Pig. What are these? So initially HDFS and MapReduce, later these Hive and Pig are added to the community of this big data. So what are these? Okay, let me tell you what are these. So Hive is used to process structured and semi-structured data. Structured and semi-structured data without Java coding. Without Java coding. Without Java coding. Okay. It can process only structured and semi-structured. Then coming to Pig. Pig can process structured, semi-structured and unstructured. All these three varieties of data with a separate language, not Java language, with a language called as Pig Latin. It is very easy. This language is very easy to use compared to Java language. Very easy compared to Java language. Okay, Hive and Pig. So Hive uses, mainly Hive can process structured and semi-structured. So what is the language that is used by Hive without Java coding? This uh, Hive is using a language called as HQL. HQL stands for Hive Query Language. This language is very much similar to almost the same as SQL. Okay, Hive Query Language, it is same as SQL. So therefore, the people who are SQL developers, they can use a Hive component to process the data. Okay, they need not to go with MapReduce. They can use directly Hive to process the data. Okay, so if you want to go with directly MapReduce, compulsory we have to write Java program. But I am not good at the programming in Java. Then what I have to do? So in that case, you can use Hive, and you can use language called as HQL. So when you write queries in HQL, automatically the Hive engine is going to convert that into a corresponding Java program. Okay, the Hive queries, whatever we write here, that queries will be internally converted into Java programming only. The thing is, we cannot skip from this, we cannot escape from the Java programming, but we can skip this. That is, we can say that Hive language HQL is an abstraction or higher level to MapReduce programming. That is, we need not write MapReduce programming, we write only queries. Those queries will be internally converted into MapReduce program that will be taken care by Hive engine. So we need not to worry about that. Directly we can use Hive. So this Hive is mainly used for structured and semi-structured data. Structured in the sense tables, the data is written in the form of rows and columns, and semi-structured in the sense some JSON data, XML data, and the CSV data, TSV. So all the different files types of data can be processed by using Hive. Okay. Next, coming to Pig. the component pig. So it uses a language called as pig Latin. It is very easy, very easy to use, very easy to use. Okay, and when you write the scripts, here we call as scripts. Here we call as queries in Hive, and in pig we call them as pig scripts. So when we write some pig scripts, by internally they will be converted into again MapReduce program only, that is Java program only. Okay, remember that. So pig uses the script. In turn, this pig is again the script is again converted into a Java program. So ultimate thing is whether you are using Hive, whether you are using pig, internally what's going to happen? Both are getting converted into, whether it is queries, whether it is Hive queries or whether it is pig scripts, whatever it may be. Both internally will be converted into MapReduce program. So we can escape from programming, MapReduce programming from here. So what type of data can be processed by MapReduce? So that is directly you can use MapReduce programming if you are good at Java. Otherwise you can use Hive or you can use Pig. Okay. What type of data can be processed by Hive? Hive can handle structured and semi-structured, but not unstructured. Okay. Pig can handle all these three varieties of data. Okay. But internally these three are based on MapReduce. So ultimately we can say that what is the processing component in Hadoop is simply we can say MapReduce, that's it. Okay, whether it is Hive or pig or directly MapReduce, the underlying ultimate, the final processing component is MapReduce only. Okay, so this is a conclusion we can make from this Hadoop, and this Hadoop is very good at processing of big data. Processing of big data. So just now we have seen what is big data and what are its characteristics. Okay, processing of big data. Now the thing is, we have the data in the first in the beginning we have discussed that the companies are increasing their business. Why they want to process the data? They want to process the data to increase their business. Okay, so what data, whether historical data, whether historical data or live data, which data they are using for increasing their business, whether historical data or live data. So before some 5-6 years ago, they used to take historical data and they used to process the data and they used to get some information out of it, and they used to use this information for increasing their business. That is called as historical data. Historical in the sense the data was already collected data. It is called as already collected data, already gathered data, already accumulated data. Okay, that data they used to process in Hadoop environment by using HDFS and MapReduce. But nowadays, they are not going with historical. Okay, they are using historical. They are processing historical data as well as they are interested in processing live data. Okay, live data. So if I'm browsing on YouTube now, within 2-3 minutes, it has to understand what my nature is, what type of videos I am browsing. That is based. Previously they used to attract the users based on their browsing history, for some 1 week or 1 month like that. But we are not waiting for, the companies are not interested in waiting for 1 week or 1 month these days. They are interested in knowing the behavior of the user instantly, very near real time. That is, in span of minutes only, I would like to know the behavior of the customer or the user, so that I can attract that customer very easily. So for that, the live data has to be processed. Okay, so this live data has to also be processed. The industry is demanding the processing of live data also. So HDFS and MapReduce. This MapReduce is very good, very good at processing historical data. That is, we call this, the processing of historical data is called as batch processing. Batch processing. Okay, so this MapReduce is very good at processing historical data, but it is not good at processing live data. Not good in the sense, what do you think mean by that? It is not fast. Why? Because if live data has to be processed, the result has to be very fast. Okay, but MapReduce is not that much fast. It is slow, not fast. It is slow. Okay, once it starts, the application starts executing, starts processing, it will become fast. But to start the application, to start the processing itself, it will take some time. Okay, it will take some minutes of time. So MapReduce is very good at processing historical data, that is called as batch processing, but it is not good at processing live data. Then what is the solution? So to what is that, to overcome this problem, in order to process the live data, there the Apache, the people, okay, the big data has came up with the big data world has came up with a new component that is called as Spark, called Spark. Okay, the developers of Spark, they have established, now they are running a company called as Databricks. The founders of Spark, they are established a company called as Databricks. So to overcome the limitations of this MapReduce, what are the limitations of MapReduce? Here we are seeing only one limitation, that is it is not fast, it is slow. It is good at processing historical data, but is not recommended to use for live data processing. So for that, to overcome these limitations of MapReduce, to process this live data also, they came up with a component called as Spark. Okay. So what is the purpose of this Spark is, the purpose of this Spark is to process live data as well as historical data also. Okay, the thing is, it is very faster. The Spark is very faster than MapReduce. How much faster? The Spark is minimum 10 times to maximum 100 times faster than Spark. Sorry, faster than MapReduce. Okay, so they came up with a new component called as Spark, which can be minimum 10 times and maximum of 100 times faster than MapReduce. It can process historical data as well as live data. It is very good at processing historical data as well as it can very good at processing live data also. That is why the industry is moving to Spark instead of MapReduce. Now you may ask, Spark is used for only for processing, then what about the storage? When we use this Hadoop comes with HDFS and MapReduce, but does not come with Spark. Spark is a separate component. So if the data is stored in HDFS, then only we can process it. So MapReduce can process it here. But what about Spark? Spark doesn't have any storage system for it. It is only a processing system. Then where from it can read the data, where the data has to be to process the data by the Spark. So the data can be in HDFS. If the data in HDFS, yes, Spark can read and process it. Okay, Spark can process if the data is in HDFS, no problem. So what are the different file systems from where Spark can read and process the data and MapReduce HDFS? Let me show you that. Okay, this is Hadoop environment. Let us say this. So let us say this Hadoop environment. Let us say some cluster made up of some machines. Let us say I'm giving some random figure here. Okay. So in this cluster, we'll have HDFS as well as MapReduce. Okay. So where from it can read the data? Where from it can read the data? In what mode? Okay. So it can read from different varieties, different storages in two modes that I told you, in batch mode, and another is in live mode. That is, live mode is also called as stream mode. Okay, to bring the data, to move the data into Hadoop environment so that the data can be processed. Okay, so where from it can bring the data? It can bring the data from local file system, it can bring the data from RDBMS, okay, or it can bring the data from NoSQL databases. NoSQL databases. What is NoSQL database? HBase and Cassandra, MongoDB, all these are called as NoSQL databases. These are also big data, big data databases. We can say that simply big data databases. Okay, NoSQL. No stands for not only SQL databases. So I'm from a web log, log servers. That means which provide the data, which read the data continuously. So the data can be moved into Hadoop environment either in batch mode or in stream mode. So from RDBMS or from NoSQL database, some file systems, the data can be moved into Hadoop environment in batch mode. But from servers, mainly log servers, weblog servers, the data can be moved into Hadoop environment in stream mode. That is, the data will come continuously from this. For this, some other components are used. They are called as Flume, Kafka, Storm. All these are different components from by using which we can move the data from external servers into Hadoop environment in stream mode. Okay, these are in stream mode. These move the data into Hadoop environment in stream mode, and remaining they move the data in batch mode. Okay. Similarly, Spark also can read the data from many sources. Okay. So now the thing is, see here, if you want to process some data by using MapReduce, remember here, if you want to process some data by using MapReduce, compulsory the data must be in HDFS. Okay, Hadoop will come with two components, HDFS, MapReduce. If you want to process the data by using MapReduce, compulsory the data must be stored in HDFS. That is the condition, that is the tight coupling we have between HDFS and MapReduce. The data must be in HDFS to process the data by using MapReduce. Okay. Next, but there is one, and let me show you the problems with MapReduce. MapReduce is, it is slow. Actually, it is slow. It is not recommended for what? Stream processing. That is live processing of data. It is not recommended for live processing or stream processing. And second option is, it is tightly coupled with HDFS. That is, the data must be in HDFS, then only MapReduce can process it. Okay, but these limitations we can overcome with Spark. Okay, so it is very fast. Spark is very fast. It can do both batch processing as well as stream processing. That is, historical data processing as well as live data processing. And coming to this one, next, coupling, it is not tightly coupled with any subsystem. Okay, not tightly coupled with any file system, or RDBMS, anything, or NoSQL. You can see this here. If the data is a NoSQL database, HBase, let us say Cassandra or MongoDB, the data must be moved to HDFS for processing by using MapReduce. And similarly, if the data is some RDBMS like MySQL, Oracle, like this, Oracle servers, the data must be moved to HDFS for processing by MapReduce. Likewise, if you want to move some data into HDFS, and after moving, and if they want to process the data compulsory the data must be moved into HDFS for processing. That is the nature of MapReduce. But in this case, in case of Spark, okay, the data need not be in HDFS. Directly it can read the data from Spark. It can process the data directly. It can read from local file system. It can read from HDFS. The data can be in HBase. Okay, the data can be in some RDBMS, the data can be in Cassandra, where whatever may be the whatever may be the type of storage, whether it is a file system or RDBMS or NoSQL database, whatever it may be, it can access the data from anywhere and it can process it. Okay, the data need not be in HDFS. It can be in HDFS or it need not be in HDFS. It can be in any file system, or it can be any RDBMS, or it can be any NoSQL database. So it can read from any file system and it can process it. So that is the advantage we have with the Spark. Okay, and what is the language that is used for writing Spark programs? I told you that for writing MapReduce programs, what is the language that we need to use? We need to use Java language. Okay, but for writing Spark programs, Spark applications, we need not to go with Java. But if you want, you can go with Java. We can use Java language or Scala or Python or R language. These are the four languages in which we can use the language we can use for programming Spark applications. Okay, there is much flexibility even with respect to programming also when we compare Spark with MapReduce. Okay, right, and still, if you do not want to use the programming, Java programming or Scala programming, Python or R language, still you can use uh, let's say, still you can use SQL also is Spark. Okay, so as we are using Hive in instead of MapReduce, what we have been using there, Hive and Pig. Okay, similarly, if you do not want to use these languages, still you can use SQL also here. Still you can use SQL directly. And what type of data can you process by Spark? Yes, structured, semi-structured, as well as unstructured. These three varieties of data can be processed by using Spark. Okay, we can use SQL also. So this is the introduction to this Hadoop, HDFS, MapReduce, and Spark. Brief introduction. This is only just brief introduction. So in our course, we are going to discuss about all these components, Hadoop, entire Hadoop. We will start with HDFS and MapReduce, then Hive, Pig, HBase, Cassandra, and we also use streaming components like Flume and Kafka, and after that Spark. Okay, the entire Spark has totally five components, but in that I'm going to give you the info, about we are going to discuss about only four components, that is Spark Core, Spark SQL, Spark Streaming, and Spark Machine Learning. So these four components we are going to discuss as part of Spark. Okay, and with respect to big data, these are the different components. These two are the streaming components. Okay, and these are the NoSQL databases. NoSQL databases. Okay, these are the topics that we are going to cover in our entire course. So this may take of almost 50 sessions. 50 sessions. Each session will be of 120 minutes. Be of 120 minutes. So if you want only Spark, that will end up with 25 sessions. 25 sessions, and again each session is of 120 minutes. Okay, if you are all including Hadoop and Spark, it will take 50 sessions, and only Hadoop, it will take 25, only Spark it will take again 25. So combinedly totally 50 sessions it is going to take for both Hadoop as well as this Spark, including all these components. Okay, na? Any questions, sir?
Kanaka, this is Malay.
Yeah.
So when you say that MapReduce and that is replaced mostly by Spark,
Hmm.
and how this architecturally different because both are writing in the Java,
Hmm.
and MapReduce also written in the Java, and Spark also can written in the Java. Why don't we improve the MapReduce itself with Java? So what is the architectural difference?
Yes, sir. Let me tell you. In Hadoop, HDFS and MapReduce. Actually, MapReduce for computation purpose, okay, processing purpose. Now, we have one more common called yarn. It is called as this is the cluster. HDFS is the cluster for storage, and yarn is the cluster for processing. Yarn is a cluster for processing of data. Okay, it provides a cluster for running for storage of data, and yarn is a cluster for processing of data. Remember this. Okay. On yarn, so coming to this yarn or HDFS, both HDFS also, these are master slave architectures. These two are master slave architectures. Okay. HDFS and yarn. In HDFS, there are three daemons mainly: name node, data node, and secondary name node. These three are the daemons which are used for creating a cluster of HDFS. Name node is a master process, and secondary name node is also one more master process, and this is going to be the slave process: master, master, and slave. So in the HDFS cluster, in the Hadoop cluster in HDFS, these are the demands that are going to run: masters, name node, secondary name node, and several data nodes. Why? Because the slaves will be more. Masters will be one, but slaves will be more. So this is the architecture that is used by HDFS. And the yarn, coming to yarn, yarn uses two processes. One is called as resource manager, and that is called as node manager. This resource manager is the master process, and node manager is the slave process. Okay, so in the HDFS cluster, these are the daemons that are going to run, and in yarn cluster, these are the daemons that are going to run. Okay, so to this cluster, yarn cluster, we can submit MapReduce programs, or we can also submit Spark programs also. Okay, we can submit either MapReduce applications or Spark application to yarn. So for running Spark applications, we need not have a separate cluster. We can have Hadoop cluster. If we have Hadoop cluster, obviously that is Hadoop yarn is available from Hadoop 2 onwards, 2.x onwards. So from Hadoop 2 onwards, yarn will be there. So we can use already existing yarn cluster to submit these Spark applications. Okay, the architecture will be like this. Okay, nodes. These we call nodes as nodes, and in all these nodes, what daemons are going to run in all these nodes? Okay, so one system or one or two systems, one or two machines that we allocate for masters, and remaining nodes we can use for slaves. Remaining nodes we can use for slaves. So master in the sense name node, or you can use secondary name node in another machine, whatever it may be. And in all the slave nodes, data nodes are going to run. Data nodes. With this is the cluster with respect to HDFS. Okay, data nodes or the data nodes. Okay. Now, and with respect to yarn, in the same machine, this is Hadoop cluster, right? So if you think the Hadoop cluster, it is made up of HDFS and yarn. Yeah. With respect to HDFS, these are the daemons that run in all the machines. And with respect to yarn, what are the daemons that run in all these machines is in masters we can have RM, that is resource manager, and in all the slave machines we'll have node managers, NM. Okay, likewise, this node manager will be there in all the machines, like this. So this is the a simple rough sketch of this architecture of this Hadoop environment. Okay. So to this application, to this environment, to this yarn, we can submit Spark applications also. Okay. We can run MapReduce applications as well as Spark applications in this cluster. Okay. Is it clear, sir?
Yeah, it is clear. Thanks, sir. But when you mention
Hmm.
in the yarn also have the name node and HDFC also have the name node. One is a master, one is a slave. So how you differentiate? How to know that?
Sir, your voice is very low, sir. Can you increase the volume?
Uh, are you able to hear me clear now?
Yeah, okay, now. Tell me.
Yeah, the question is, we have the name nodes in HDFS HD file system, and we have name node in the yarn, which
Hmm.
is one is a master, one is a slave, right?
Hmm.
So how you differentiate between the slave and master, because both are the name nodes?
Differentiate between what's the name node and?
Uh, See, you mentioned there is a name node in the HDFS file system, that
Yes.
is a master.
Yes.
And also you have mentioned one more name node in the yarn, which is slave.
No, sir. Name node is not the part of yarn. Okay, it is part of HDFS only. Name node.
Okay.
Name node is the daemon of HDFS, not that of yarn. Uh,
Okay. Yarn, you have resource manager, and what is the another one?
Node manager. Node manager. Just let me show you this. Okay. In HDFS, name node, secondary name node, data node. In yarn, resource manager and node manager.
Got it. Okay.
Okay.
I can.
Okay. Okay. Hari sir, anyone? Any questions? MapReduce and Spark are using same yarn. Yes, same yarn. Yes, Chakra point sir, they use the same yarn. So same cluster can be used to run MapReduce applications as well as Spark applications. Are using same. Why? So sir, why they are using yarn in the sense? See here for running Spark. So running Spark applications, yarn is not mandatory. Okay, listen one more thing here. So I want to run one Spark application. Okay, so what is the cluster needed? Either you can deploy Spark applications to yarn cluster, or you can deploy Spark application to Mesos cluster. There's one more cluster called as Mesos, and the cluster can be another cluster will be there that is called as standalone. Okay, in order to run MapReduce applications, compulsory we should have yarn. Okay, but for Spark applications, the cluster need not be yarn. It can also run on yarn. Spark applications can also run on yarn, but it need not be always yarn. It can be a Mesos cluster or it can be standalone cluster also. There are three different clusters on which Spark application can run. Okay, it is not coupled with, tightly coupled with any cluster to process it also. If we have already Hadoop cluster, you can go with yarn. That is the thing. Okay, there are the flexibilities that are provided by the Spark developers for running Spark applications. Is it okay? Any other questions? Any questions? If you can ask directly. Otherwise, you can put them in the chat.
Karnakar, this
Yeah,
Chakrapani.
yeah, sir.
Uh, we are using YAR is a process for both map reducing and Spark. So how become the Spark going to be faster processing?
No, sir. It is the architecture. It is the underlying, architecture of Spark that makes Spark application to run faster. Okay. Yarn is independent. Yarn is not, dependent on MapReduce, or Yarn is not dependent on Spark. It is totally independent. It provides an environment. It provides a cluster environment to run one distributed application. That's it. MapReduce can process the data in distributed mode. Similarly, Spark also can process data in distributed mode. So if you use MapReduce, it will be slow. That is not the nature of yarn. That is the nature of MapReduce. And if you use Spark application, Spark is faster. The internal architecture of Spark will make that application to run faster. There are many features in the Spark like resilience, persistence, stages, and lazy evaluation. There are different features in the Spark that will make Spark to speed up its processing. Okay, this is not the behavior of yarn. It is the behavior of these separate components. Okay.
Okay, okay, thank you.
Okay. Any other questions? Hari sir, I think Vivek sir, are you there? To learn Hadoop, what is the minimum requirement? We need to be expert in Java. Need not be expert in Java. That I am telling you, need not be expert, but we should know Java. But we should know Java. If you want to learn only, need not be expert, but there are some concepts are there mainly um, in Java. Let me just give you the list of the components that we must be good at. In Java, we should know what is a class and what is an object and interfaces. We should know about interfaces, abstraction, and inheritance. Simply you can say the OOPS concepts. Okay, these are the minimum, knowledge we should know about. We should have about Java. Then only we should know about JVM, Java Virtual Machine. Okay, this will be sufficient. Don't worry, whatever the knowledge that is required for either in Java programming language means Scala programming language for Spark, I will give you that information. I will provide that you know that information to you also with Java also. Don't worry about that. Okay.
Yeah, Karnakar Vivek here. Hello.
Yeah, away.
Yeah, yeah, yeah. You will be providing a section on that, or you will be providing some required documentation. How you are planning to cover that? The basics of Java.
The basics of Java, I will give you practical sessions in the class, in the conducting classes, and theory concepts. What are the required? I will prepare. I will have a documentation. The documentation I will share with you. Okay.
Okay. Now, what I meant to say is, if you means whatever is required basic level, that you can share as a document or practical separately, because we may lose the focus of the big data if we focus on the Java.
Yeah.
So those who really want something more than what is required in Java, then they may get into some other session for that.
Yeah.
But I want to be focused more on the subject rather than again focusing on the basics.
Okay. Don't worry. I don't get into the depth of the Java yet. Whatever we do MapReduce programming, we do Spark programming. Whatever the concept that is required for that programming, that I will discuss in the class. That's it. Okay. I'm not getting into depth of that. If you want separate classes for programming, I will separate I will conduct the classes separately for them. Okay. Don't worry about that.
Okay.
Karnakaran, this is Sunil.
Yeah.
So basically, like I want to if you really want to learn this Hadoop, okay, let's suppose you are starting maybe tomorrow you are starting.
Okay.
So as before joining it, what is that really we need it, because we are from a background of BI, I am working as a HANA modeler and reporting tools.
Yeah,
okay.
Yeah.
So I don't know anything about Hadoop. Okay. So that previous skills, is it joining, or do I need some other skills before taking up this Hadoop training?
Yes. So I'm giving you here. We should have the knowledge of Linux. Okay. We should have the knowledge of programming Java. And to take up this Spark, if you want to go with only Hadoop, Linux is required, Java required. And in addition to that, you require some knowledge of SQL. Okay. SQL is required. That's it. These three knowledge of these three Linux, and you say how do we use a Linux environment? Reading of files, creation of directories, deletion of directories, setting permissions, all this stuff. At least the basic stuff we have to know. And with respect to
Okay.
Java, these are the concepts I have listed here. And with respect to SQL, we'll have two types of commands: DDL commands and DML commands. That is creation of table, creation of database, inserting into it, deleting the data, deleting tables, deleting databases. That stuff you have to know. Okay.
Okay. So how much the percentage, like in Hadoop, each these three levels are involved? Like if see SQL is part of our regular job, so we are 100% good in SQL. So
Okay.
when coming to Java, Linux, yes, is a basic.
Yeah.
But for this training Hadoop, like how much is skills is categorized in these three? Like how
Okay.
much you are Hadoop as a consult developer or an architect, how much they are involved in each level in a regular basis?
Yeah. If you are going purely with Hadoop admin, there are openings for admin as well as developers. Okay, if you are going for Hadoop administrator, then you must be very good at Linux. Very. Okay, you have depth knowledge of Linux. But as a developer,
Okay.
you need not to have the depth knowledge of this Linux. You need to have some
Okay.
50% or 40 to 50%. That's it.
Okay.
Okay, and
Okay.
coming to Java, as a developer, you should have sound knowledge. I'm telling you frankly, you should have good knowledge of Java. Okay, good
Okay.
knowledge. I don't say just only these are required, but if you want to work all this with all these concepts, compulsory you should know the basics. With you, unless you know the
Okay.
basics, you can't work with all the inheritance, the interface, all these things. So you should have the good knowledge of
Okay.
it. Okay.
Okay.
Okay. And coming to SQL, already you are good at SQL. So I say that
Yes.
50%, and the Java also I say that I cannot give a percentage for Java. Why? Because it's a programming language. I cannot give, but still I can. If I can give some 50 to 60%.
Yeah.
Like this.
That's learning is not just learning and understanding what is Hadoop and everything, right?
No,
So
no.
to really, yeah, so really start working, we should know basically all these things, right? So
Yes.
uh, before I join, I should understand, okay, by parallelly while your sessions, should I get this knowledge and I can get into it, or before joining, should learn this and come and join? That's what my question. So, okay,
You can go parallelly, Sunil. Why? Because learning all this stuff will take again some time. So you can go parallelly. It doesn't, understanding the concept doesn't require the programming knowledge, right? The
correct. That's what I'm saying.
mm,
Understanding is not required, but really
you
to
can go
work on
parallel.
some project.
You can go parallelly. Language. The thing is, you have to spend some extra time.
Okay,
That's the thing. So whenever if you want some extra time, if you can spare some time, I will give you the knowledge of this language also. Okay, how to use, and in a very simpler manner, I will give the knowledge. Okay, I will provide the knowledge. Don't worry about this. But thing is, I suggest you to go parallelly. Okay, don't separate them. And go parallel.
okay.
Okay. Any more questions? About installation practice in our systems? We need expert in Java. For the installation, we are going to learn entire in Cloudera distribution. You can download Cloudera VMware directly from net. Okay, Cloudera Hadoop distribution. The latest version is 5.12, 5.12.0, but I suggest you to go with 5.10.0. Download this version. Why? Because the certification in Hadoop is also they are providing, they are conducting exam in this version only 5.10. So I suggest you go with 5.10 of Cloudera. You can download this VMware. Okay, Cloudera VMware directly from Cloudera site, and you can use it as a VMware. For that, system requirement must be at least you need to have 10 GB of RAM. You require at least 10 GB of RAM. Okay, see that you have 10 GB of RAM, without which this will not work. Okay, why? Because already you are working people. I do not want to go with some Apache products. I want you to go with distributions only. Why? Because industry uses distributions. So I will teach you the entire course in the Cloudera distribution 5.10.0. So take it, and I will show the installation steps also. Okay, don't worry about that. How to use it and where to start. and how to open, how to close, everything I will give you the information of it. Okay. Mm, I think this is the question posted by there is no name here. Okay. Any other questions? Okay. If no questions, then I think a group is created by someone, big data. Someone has created this group. I don't know who has created this group. I did not go through it actually. Just to make me, give me the confirmation and your time schedule. Just discuss among yourself and give me a time so that we can have the classes. Okay. Let me know the time by the end of the day. Okay, sir?
Yeah, yeah, sure.
Sure. Okay. Thank you. Thank you, everyone.
Thanks.
Bye.
Thank you.